All right, listeners, you've really thrown us for a loop with
Hmm.
this source material. I mean, we're talking seriously mind-bending stuff today. Some really fundamental ideas about how the universe works are, well, up for debate. Gravity, the Big Bang, even time itself,
Yeah.
like it's all on the table.
It's really fascinating. This source is really proposing a complete paradigm shift. It suggests that maybe, just maybe, everything we thought we knew about how the universe works is maybe, well, kind of backwards.
Backwards. Okay, I'm listening. What do you mean by backwards?
Well, the source is arguing that instead of gravity being that fundamental force pulling everything together, it's actually spin. Like spin comes first.
Well, the spin creating gravity, that's a pretty wild idea. How does that even work?
Well, think about it this way. Like everything in the universe, spins, right? I mean, from these tiny little atoms to these massive galaxies. So what if this universal spin, it's like the underlying mechanism behind gravity.
So instead of the Big Bang being this huge explosion where gravity is slowly pulling things together over billions of years, you're saying the universe was like born spinning, and that spin created like the conditions for gravity to emerge.
Exactly. It's a total flip, right? Like a
Yeah.
complete flip of the script on how we've always understood, the way the universe evolved.
Okay, I'm trying to get my head around this.
Mm.
Is there any evidence to support this whole spin first idea?
Well, the source points to black holes as a really compelling piece of the puzzle. You see, there's these theoretical black holes. They call them Schwarzschild black holes, and they're basically black holes that don't rotate. Just a point of infinite density.
Right, I've heard of those, but those are just theoretical, right?
And that's the thing. Every single black hole, that we've actually observed out there in the universe, they all spin. These spinning black holes, they're called Kerr black holes, and they actually twist space and time around them. It's this phenomenon that the Schwarzschild model, the one that doesn't spin, just can't explain.
So if spin is so fundamental to these incredibly powerful objects like black holes, could it be that spin plays a much, much bigger role in the universe than we ever, even imagined?
That's the question this source is really asking us to consider, and it gets even more interesting, even more mind-blowing when you start to think about time.
Okay, here's where I get lost.
Yeah.
Time, moves forward. It's like a one-way street. But how does that actually work?
The source uses this really interesting analogy. It compares time to a give. That stretchy elastic material. Imagine you stretch a give out, and then when you let go, what happens?
It snaps back to its original shape.
Exactly. And that's what the source is suggesting. It's saying that time might have a similar tendency to recoil or flow in a specific direction.
So instead of time being this rigid, unchanging dimension, maybe it's more like a force.
I wouldn't say a force exactly. It's more like a fundamental principle of directionality. And if spin is as fundamental as this source suggests, then perhaps that initial spin of the universe, that set the direction of time's arrow, like which way it flows.
Whoa, that's a lot to take in. And this all connects back to those Planck units you mentioned before, those smallest possible units of space and time.
Right, exactly. Think of Planck units like the pixels that make up a digital image. They're like the tiniest, the most fundamental building blocks of the universe. The source proposes that when you twist a Planck unit, like if you imagine adding spin to it, you actually might create a mini black hole.
Wait, mini black holes like popping in and out of existence at the smallest level of reality? Now my head is spinning.
It's pretty wild, really. But, and here's the kicker, it doesn't even stop there.
Yeah.
This source also raises this mind-blowing question. What if time itself, like time, is actually a form of energy?
Okay, hold on. Time is energy. How is that even possible?
Well, think about how we traditionally view time, right? It's this constant ticking dimension. But what if that's not the whole picture? What if time is more dynamic, more fluid, and directly influenced by energy?
So you're saying our understanding of time as this steady, unchanging thing is completely wrong.
Well, this source is certainly challenging that assumption. What if time is more like a river constantly flowing, and the rate of that flow can be influenced by the energy within it,
Okay, I can see where this is going. So if energy is time, could we manipulate time by manipulating energy? Could we slow down aging? Maybe even reverse it?
Now, those are the million-dollar questions, aren't they? If energy truly is time, think about what that means for health and aging. What if the way our bodies age is directly tied to how efficiently we use energy?
You're saying we could potentially find ways to optimize our energy flow, and that could actually affect the passage of time, like within our own bodies. I mean, that sounds like science fiction.
Perhaps. But maybe what we call science fiction is just science that we haven't fully grasped yet. And remember, this is just the tip of the iceberg. This source goes even deeper. It suggests that all these Planck units, these tiny building blocks of the universe, they might actually be interconnected.
Interconnected, you mean like a giant network?
More like a giant symbiotic organism.
Whoa, okay, so instead of thinking of the universe as like a bunch of separate parts, it's more like this massive interconnected network, right? Like some kind of cosmic internet, where everything's constantly like communicating.
That's a great analogy. And if all these Planck units are constantly, flexing and shaping and creating these variations in energy density, well, it's almost like a giant cosmic
mesh.
Yes, a mesh, that can bend and twist and form, new shapes. A mesh that creates, everything from stars to galaxies to, well, us.
Okay, I need a minute to process this. So the universe as this giant symbiotic flexing mesh, it's a pretty wild concept.
Yeah.
But if this mesh is where gravity comes from, where do black holes fit into all of this?
That's where things get really, really interesting. Remember we talked about Kerr black holes, those spinning ones? Well, the source suggests that those spinning black holes are like extreme knots in the cosmic mesh.
Knots. So it's not just about density. It's about like the way these Planck units are twisting and tangling themselves up.
Exactly. These knots are so tight, they create these incredibly deep gravitational wells, that we call black holes. Even light, can't escape their pull because the fabric of space-time itself is being warped and twisted by the spinning Planck units.
I'm starting to see how this all ties together,
Yeah.
The spin creates the knots create the black holes, and the black holes warp space-time. It's like this chain reaction, all stemming from that initial spin of the universe.
It's a beautiful interconnected system, and if we could understand how to manipulate this mesh, I mean the implications, they'd be staggering.
Okay, I'm ready for my mind to be blown again. What kind of manipulation are we talking about?
But imagine being able to untangle those knots, like to smooth out that fabric of space-time, or being able to create new knots, like harnessing the power of black holes for energy.
Well, hold on. Are you saying we could actually like control black holes? I mean,
Wow.
isn't that incredibly dangerous?
It would definitely require an extremely advanced, level of understanding and technology. But if we could crack the code of this cosmic mesh, I mean the possibilities, they'd be practically limitless.
Limitless. That's a bold statement.
Think about it. If we could manipulate the mesh, I mean, we might be able to, control gravity. We might be able to generate energy, on a scale that we can't even imagine. Maybe even create wormholes, for interstellar travel.
Okay, now you're really getting into like science fiction territory. Wormholes. That's like something straight out of Star Trek.
Perhaps. But remember what seems like science fiction today, it could be, scientific reality tomorrow, and who knows? Maybe this whole theory of the universe as this giant interconnected mesh, maybe it's just the first step towards unlocking a whole new realm of possibilities.
All this talk about black holes and manipulating space-time, it's really making me think about the bigger picture. Like what does this theory mean for our understanding of the Big Bang?
It's a great question. If we accept this idea that spin is fundamental and that the universe was like born spinning, it really challenges our traditional understanding of the Big Bang, doesn't it?
So it wasn't just a massive explosion.
Maybe it was more like a cosmic vortex. Like imagine all the energy and matter of the universe just swirling and spinning, and creating the conditions for gravity to emerge, like right from that initial rotation.
A cosmic vortex. It's a much more dynamic picture than like the classic Big Bang theory. It's almost like the universe was like destined to be in constant motion, constantly evolving right from the very beginning.
Exactly. And that initial spin, like that primordial vortex, it would have, set the stage for everything that followed. The formation of galaxies, the birth of stars, the emergence of planets, and ultimately life itself.
So it's not just about the universe, expanding outwards. It's about this constant interplay of spin and energy and matter, all shaping and reshaping this cosmic mesh.
Precisely. And if time itself is a consequence of this universal spin, as this source suggests, then our understanding of the Big Bang, I mean, it needs a serious rethink, doesn't it? It's not just about, the beginning of space and matter. It's about the beginning of time itself.
Okay, my head is officially spinning again.
Right.
We've got black holes as knots in the cosmic mesh. The Big Bang is this cosmic vortex. It's also incredibly, interconnected. But I have to ask, if time is a consequence of spin, does that mean time could flow differently in different parts of the universe?
That's a fascinating question, and one that this source doesn't explicitly address. But if time is truly intertwined with the fabric of space-time, and that fabric is being warped and twisted by things like black holes, well, it's certainly possible, isn't it, that time could behave differently, in those extreme environments.
So time travel might not be as far-fetched as we thought.
We're definitely wading into like some speculative territory here. But if this theory, holds water, I mean, it opens up some truly mind-boggling possibilities.
Mind-boggling is an understatement.
Mhm.
I feel like we've barely scratched the surface of this theory, and we're already talking about like manipulating black holes and bending time.
And we haven't even touched on the implications for healing and longevity.
Oh, right. We were talking about that earlier. So how does this idea of the universe as a giant mesh tie into the potential for like extending lifespan, or even achieving some form of like immortality?
Well, if we think about the human body as just another pattern, within this cosmic mess.
Like a smaller, more intricate knot.
Exactly. And if aging is simply the result of those knots fraying or becoming tangled over time.
Then maybe we could find ways to repair those knots.
Yeah.
Like to smooth out the fabric of our own personal space-time.
That's the idea. If we could understand how to manipulate, the mesh at that level, we might be able to slow down aging, to reverse damage, maybe even achieve a form of like biological immortality.
Immortality. I know we're like deep into speculation here, but that's a pretty big leap.
It is, and it's important to remember that we're talking about a highly theoretical framework here. But if this theory is even partially correct, it suggests that the human body and indeed all of reality is far more malleable and interconnected than we ever imagined, and that in itself is a pretty mind-blowing concept.
It definitely is. But before we get like too carried away with dreams of immortality, I want to come back to something you mentioned earlier about healing. If we could manipulate the cosmic mesh, wouldn't that mean we could potentially cure any disease?
It's certainly a possibility. Imagine being able to untangle the knots that cause cancer cells to multiply, or to repair the frayed connections that lead to neurodegenerative diseases.
It sounds almost too good to be true.
Of course, there are countless challenges and ethical considerations to address before we could even begin to explore these possibilities. But the potential, it's undeniable.
Okay, I'm officially overwhelmed. We've gone from spin creating gravity to black holes being knots in the cosmic mesh to potentially like curing diseases and achieving immortality. It's a lot to process.
It is a lot to process, but that's the beauty of these deep dives. We're exploring ideas that push the boundaries of what we thought was possible. Forcing us to reconsider our place in the universe and the very nature of reality itself.
And you know what? Despite like the overwhelming nature of all of this, I'm left with a sense of like optimism. If this theory is even partially correct, it means we're not just passive observers in this predetermined universe. We have the potential to understand and maybe even shape the very fabric of reality.
That's a powerful realization, isn't it? And it leads us to the ultimate question. If the universe really is this dynamic, interconnected system of spinning energy, I mean, what are the limits of human potential?
That's a question for the ages. But I have a feeling that as we continue to explore the mysteries of the universe, we're going to find that the limits are far beyond anything we can currently imagine. I'm still trying to wrap my head around all of this. So we got this universe, right? It's like a giant interconnected mesh of energy, and within this mesh, you've got these tiny Planck units, and they're constantly spinning and twisting, and that's creating the force of gravity.
It's a fascinating concept, isn't it? And if we really follow this line of thinking, it leads to some really mind-bending implications for how we understand the universe and our place in it.
So walk me through it. If we zoom in on this cosmic mesh,
Yeah.
what are we actually seeing? Like how does all of this work at the smallest level, you know?
Yeah. Okay, imagine the universe, right? And it's this vast, intricate tapestry woven from countless tiny threads. And those threads, those are the Planck units, like the smallest possible units of space and time. And just like the threads in a tapestry, they create patterns and textures, right? These spinning Planck units, they create these variations in energy density, and that's what we perceive as gravity.
Okay, so the denser areas in the mesh, like where the Planck units are more tightly packed and spinning more rapidly, those would be the places where gravity is strongest.
Precisely. Think back to that trampoline analogy we used earlier. You know, a bowling ball and a trampoline, it creates a dip, and anything you roll near that dip, it's going to curve inward towards the bowling ball.
Right. Because the bowling ball is warping the fabric of the trampoline.
Exactly. Now imagine that trampoline is the cosmic mesh, right?
Yeah.
And those dips, they're created by the denser, more rapidly spinning clusters of Planck units. And those dips, those are what we perceive as gravity.
So black holes would be like those super dense bowling balls, right? In the middle of the trampoline, creating these incredibly deep dips that warp the fabric of space-time so severely that even light can't escape.
That's a great way to visualize it. Black holes, they represent the most extreme warping of the cosmic mesh, where the spin and the density of those Planck units have reached this incredible level, and that's what creates those profound gravitational effects.
Okay, so if we could like somehow understand and manipulate these Planck units, could we control gravity? Like could we create artificial gravity field? Maybe even build those anti-gravity devices we see in science fiction movies.
It's certainly a tantalizing possibility. If we could learn to manipulate the spin and the density of those Planck units, we might be able to create, localized variations in the cosmic mesh, effectively controlling the gravitational field.
That would be incredible. Imagine the implications for space travel, for architecture, for medicine even.
The possibilities are truly mind-boggling. But of course we're talking about a level of technological advancement that's far beyond anything that we can currently achieve. I mean, understanding and manipulating the fundamental fabric of the universe is no small feat.
No kidding. But it is exciting to think that maybe, just maybe, the seemingly outlandish theory, it could be the key to unlocking some of the universe's greatest mysteries.
It definitely pushes the boundaries of our current understanding. It forces us to consider new possibilities. And you know what? Throughout history, what was once considered impossible has often become commonplace. I mean, just think about the internet or smartphones or even space travel itself.
It makes you wonder what incredible breakthroughs, might be just around the corner. Speaking of breakthroughs, we talked earlier about the potential for this theory to revolutionize healing and even extend, human lifespan. How exactly would that work?
Well, if we think about the human body as just another pattern within this cosmic mesh, a complex interplay of spinning energy, then aging, disease, death itself, it could be seen as like disruptions or imbalances in that pattern.
So if we could find ways to rebalance those patterns, like to smooth out the disruptions in the cosmic mesh that make up our bodies, could we essentially reverse the effects of aging and disease?
That's the idea. It's a bold concept, but if this theory, if it holds true, it suggests that our bodies are far more malleable and interconnected with the universe than we ever imagined.
It's almost like we're not just, individuals, we're expressions of this universal energy field, constantly interacting and exchanging information with the cosmos.
That's a beautiful way to put it. And if we could tap into that connection, harness the power of the cosmic mesh itself, I mean, the potential for healing and transformation would be truly limitless.
Limitless. I'm trying to wrap my head around that. Does that mean we could potentially cure, any disease?
Yeah.
Reverse any injury, even overcome death itself?
Yeah, now we're venturing into highly speculative territory here. But if this theory is even partially correct, I mean it opens up some extraordinary possibilities for human health and longevity, doesn't it? It suggests that the limits we've placed on ourselves, the boundaries we thought were unbreakable, that they might be far more fluid and permeable than we ever imagined.
That's both incredibly exciting and a little bit, terrifying. I mean, the implications of being able to control the very fabric of reality, to manipulate the forces that govern, life and death are pretty profound.
It's a lot to consider, no doubt about it. But I think it's important to remember that with great power comes great responsibility. If
Right.
if we do ever unlock the secrets of the cosmic mesh, we'll need to approach that knowledge with wisdom, with humility, and a deep understanding of the interconnectedness of all things.
Well said. And even if we never reach that level of understanding, even if we never manage to manipulate the cosmic mesh, just exploring these ideas, challenging our assumptions about the universe and our place in it, it's a valuable exercise in itself.
Absolutely. It expands our consciousness. It pushes the boundaries of our imagination, and it invites us to see the world and ourselves in a whole new light.
This has been one of the most mind-bending deep dives we've ever done. A huge thank you to you, the listener, for sharing this incredible source material with us. It sparked some truly fascinating conversations and left us with a lot to ponder.
If the universe really is this giant interconnected mesh of spinning energy where time is a consequence of motion and black holes are knots in the fabric of space-time, what does that mean for our understanding of consciousness, of the origin of the universe, and the very nature of reality itself? Those are questions we'll continue to explore as we delve deeper into the mysteries of the cosmos.